Hello! In this video, we are going to learn how to do routing in POTS. But first of all, what's the meaning of POTS? Okay, POTS is the acronym of Plain Old Telephone Service. So, before learn how to do it, we will locate the different types of exchanges. At first, we have the local centers, primary centers, secondary center, and finally the tertiary center. So, let's start with a pretty simple network. We will try to go from change E to the change A. The first path we will find is going through the high use trunk to the change B, and then take the final trunk from B to A. So the path will be EBA. Then we can think about going through the high use trunk EC. But remember, one direct section never overflows to another direct section in the same node. A high use trunk always overflows to the final trunk, so the path will be EDCBA. Okay, now we are going to try just in the other way. We will look for the paths from the change A to the change E. The first possible path is exactly the same as previously, but changing the order. We will have ABE, but do we have now any other path using high use trunks? Yes, we have it. We can use the direct section from C to E, and then we go through the path A, B, C, E. And finally, of course, we have the path to the final trunks. So we go through A, B, C, D, E. Right now, we are able to route a really simple telephone network, but are we able to do the same with a more complex network? Okay, let's try and check it. We will try to find several paths in order to fix the concept. First, we are going to start with the path from A to G. One possible path is going using the path A, B, E, F, G. Remember that in each path, we can only use one direct section, and the direct section will be used to go to a destination exchange or to a reference exchange of the destination one. Another possible path is A, B, C, F, G. And as we saw in the previous example, the next path will overflow to the final trunk, because the direct section CF can't overflow to the direct section CE, only to the final trunk. So in this case, the last possible path is A, B, C, D, E, F, G. Okay, now let's try with J to H. This one, I'm sure that will be really easy to solve for you. Obviously, the shortest path will be JH, but let's see which are the other ones. We can find JKH2. So we go now through J, K, C, E, I, H, because we can't go from K to I due to overflow. But we can use the high use trunk CD, and the last one will go through the final trunks, and it's J, K, C, D, E, A, I, H. The next one, J to G. This one is not as easy as the previous one, but don't worry, it's not difficult at all. We only have the chance of one single path using a high use trunk. That is the path J, K, C, F, G. And the obvious path, the one made of final trunks, which is J, K, C, D, E, F, G. I know you should be a bit tired right now about drawing her arrows and writing letters and doing always the same. I know what are you thinking. This is so easy, but let's do a last try and then we are going to the next thing. The last routing we are going to do will be from H to G. Really simple. You won't have any problem with it. The first path is almost like J to H. I mean, it's second possible path. So we have the path H, I, G. And of course, the last one is H, I, E, F, G. Now, we are kind of masters of routing in POTS, right? So, let's go to the next level. What about the offered and the carrier traffic? That's really easy, and I'm going to explain you continuing with this exercise. Let's suppose we have a blocking probability of 0.02 and an overflowing probability of 0.1. We also need the table with the traffic and money changes, and just as a reference, our network. So we will calculate the offered and the carrier traffic at the high usage trunk, CE, and also EC. To calculate the offered traffic, we need to find all the traffic which can flow through our selected high usage trunk. The method that I recommend you to follow is the next one. First, we choose the origin exchange. In this case, EC. And then we will find the different paths which can use that trunk. In this case, we have the traffic from C to E, plus the traffic from C to I, plus the traffic from C to H. We cannot use the traffic among C and F, nor C and G, because it will go through the direct section CF, or through the final trunk, never through CE. This is a really important issue to take into account. Okay, now, taking the origin in B, we start with the traffic among B and E. But let's see that the logic path will be ABE. So, if we want to check the traffic in CE, it will be the overflowed traffic among B and E, plus the traffic from B to I with overflow, plus the traffic from B to H with overflow. Taking the origin A, we have the same structure than before. Traffic from A to E, plus traffic from A to I, plus traffic from A to H, all of them with overflow. The next one is a bit different. We have to add the traffic among KE without overflow, plus the traffic with overflow among K and I, plus the traffic among K and H, also with overflow. Finally, we are going to calculate the traffic of the paths with their origin in J, and which goes through the high usage trunk CE. We have the traffic among J and E, the traffic with overflow among J and I, and the traffic with overflow among J and H. But wait a minute, did you notice any strange thing? Exactly. We can use at first the high usage trunk J8, and then we can go through the final trunks and use the direct section CE. But let's realize that we also can go through JK8. So we have to write down again the overflowing sign because it overflows twice. Nice. Now let's calculate the traffic with numbers. So we have the traffic from C to E, which is 20, the traffic from C to I, which is 5, and the traffic among C and H, which is 1 Erlang. With origin in B, we have the traffic from B to E, which is 3 Erlangs, but it's overflow, so we multiply it times the overflowing probability, which is 0.1, plus 5 times 0.1, because it's also overflowed, plus 10 times 0.1, which is the overflow traffic among B and H. We repeat the same with the origin A and K, taking into account that the traffics in the table are completely symmetric. And finally, we go to the traffic with its origin in the change J. I guess you're thinking, what I have to do with the traffic overflowing twice? Okay, that's very simple. You only have to multiply again times the overflowing probability. And now, let's check the result. Fine. The overall traffic is 42 Erlangs. Okay, I said that the traffic and money changes of the table is symmetric, but is the traffic in the direct section symmetric? Let's check it. I'm going to write it with green color just to compare it with the previous calculations. With the origin in A, E, F, G, I. I'm pretty sure that you won't have any problem, because it is basically the same. That be careful with the traffic among H and K, because it overflows twice too. So you have to pay attention in order to not make a mistake. And now, let's write down the numbers in the same way we did before. First, the values of the origin E, then the origin F, origin G, origin I, and finally origin H. And we have a total offered traffic of 41.39 airlines. But we are forgetting about the correct traffic, right? But don't worry. This is the easiest thing of all this video. You just need the overflowing probability and the offered traffic. Here's the formula. Let's write the carried traffic among CE in red, which is equal to 37.8 airlines, and the carried traffic among EC in green, which is equal to 37.251 airlines. Now, you are ready to try the exercises by your own. So, let's browse www.UC3POTS.tk and try to do it by yourself. See you there.